Welcome everyone to another Observability Clinic, Dynatrace for AI Observability, gaining insights and understand the behavior, performance, and cost of artificial intelligence models and services with Dynatrace. This is part of the Dynatrace from and for data scientists. I'm not a data scientist. Wolfgang Beer, you are definitely, for me, a big data scientist. You're dealing with all of these topics on a continuous basis. You just wrote a blog post about how we get insights into when your apps are leveraging AI models. And this also triggered this performance clinic, observability clinic. Thank you for being here.
Yeah, thank you for inviting me. As always, it's a pleasure for me to talk about topics around AI. And today it's really one of my favorite topics, I have to admit. And you will see in the demos that I brought with me how to monitor AI, how to monitor your own AI models by leveraging Dynatrace.
Yeah, cool. Well, then let's jump right into what have you prepared for us?
Yeah, so what you will learn today is how to monitor the usage and the performance of your AI APIs. So basically, I divided the demos into two main categories. On the one hand, how to monitor the performance and consumption and cost of external AI models, like OpenAI is one of those examples that is very popular at the moment. And on the other hand, how can you do the same monitoring and observability for your own in-house built AI models? And I used a TensorFlow Keras example for that.
Cool, but in both cases, it's really about the efficiency and how you use the OpenAI in the end, or the AI model. Yeah,
exactly. So measuring the training for the in-house model, the training performance, important model metrics like accuracy and loss, and the cost of external AI models.
Cool. And I see a dashboard with SLAs, SLOs, and with key, get the four golden signals, the number of requests, the latency, the errors, also the token consumption. I think this is something that we just talked about, that I'm not an expert in it, but this is the way AI models are charging you by the size of the request that you send in, and also by the size of the response you're expecting back. And all of this can be monitored and observed and analyzed and hopefully also optimized with Dynatrace.
In Dynatrace, yeah, right. So that's an example dashboard. You will see it in my live demo then. But let's first see how I built the demo, because those AI services are not living as isolated services, but are typically tightly integrated into your own service landscape. And that you can see here. So what I did is I wrote some example Go services, microservices that are deployed, where you see the complete Dynatrace service flow, highlighting how those services interact. So in the front end, on the left side, you see the conversational service that exposes the conversation and the requests to the real user. And then it calls a model service, and the model service then calls the OpenAI client, which leverages the native out-of-the-box provided Node.js language binding of OpenAI. And that OpenAI client basically calls the SaaS OpenAI generative service, then the large language service, and with the text question that was requested, and the external AI OpenAI service then returns the answer in terms of text, which is then traversing back, basically.
So for people that are new to Dynatrace and have never seen this, this is what we call the service flow. It's the visualization of the distributed traces that Dynatrace one agent is automatically captured. That means no code changes necessary. Now, for those folks that are listening in and that are invested in OpenTelemetry, obviously you can do the same thing if you have already instrumented your app and your libraries with OpenTelemetry. But I assume in this case, you just use the one agent.
Exactly. So the amazing thing here is that all that topological or that trace flow that you see here was automatically collected by the one agent. So there is no change at all necessary for measuring and collecting those standard service health indicator metrics and performance metrics in Dynatrace. You just deploy the one agent and you run your services. That's all you have to do. The only thing that I added was to capture the consumption metrics in terms of token consumed from the OpenAI response payload, and I will show you then how I did that.
Cool.
So, and yeah, that's exactly what I wanted to show, or what I want to show you in the live demo. So the only thing that I had to manually instrument is to capture the response of OpenAI. And you see that here in Dynatrace, we have several different ways of capturing the response of web service responses, depending very much on your use case, actually, which one of those ways you prefer. So there is the possibility of using the newly introduced BIS events to capture and parse the response of any kind of web service. And here I'm showing you the part of the OpenAI response that is relevant for us. So basically, you see the text completion message, which is returned along with the model that I requested to answer my question. And then the returning text, so the completion text is shown here. But beside that, there is also the usage that comes along with that request. So basically, I think in this case, I just requested the word hello, right? And it counts the prompt token as one. Token count always means the number of words, the number of tokens, and the prompt means the length of the question I sent to OpenAI. Completion tokens is the length of the response, right? What the model, in this case, Da Vinci model returned. And of course, you can control with a request parameter how lengthy you would like OpenAI to answer your question. And then it also returns the total tokens here. I mean, that's no surprise, but it's the number of total tokens that counts to the price. Right?
Yeah. And I think it's great to see. Thanks for the example here, because this really shows how, in this case, OpenAI really works internally when you make the API call. And as the response comes back, it not only gives the response like, hi there, how can I help you? But it also tells you how many tokens were consumed with this call, which is great because we capture it in the context of your request in Dynatrace. And so we can tell you exactly how much would you need to pay in case your app would really use this in a live production environment, and which transactions consume how much. This is awesome. Yeah.
Exactly.
Business events. Yeah. Okay.
So that business event, you can directly capture it. What I chose for me as the most convenient way, along with Grail, of course, now, and DQL, is I simply wrote one log line. That's all you have to do. And also the log line is not monitoring vendor specific, so you can use it anyway, right? Yeah. Not bound to Dynatrace. And I also, out of curiosities, I directly sent the custom metrics. But honestly speaking, I will show you both the logs and the custom metrics, but you will immediately see that the logs is much more convenient than sending it as custom metric right away.
And folks, if you listen to this, if you watch this, we will add the links to BIS events, logs, custom metrics in the documentation to this video so that you can see for yourself how this would work in your own environment.
Exactly. For logs, the only thing we have to do is to add a log parsing rule at the Dynatrace side, right? And that extracts the fields that I showed you before, the prompt tokens, completion tokens, and total tokens, and added those 3 additional fields separately at the log line that is incoming. So it basically splits out those 3 fields from the log content message. And another configuration then is necessary if you want to have those fields as time series materialized information. So of course you can go with the logs as well, and with the power of Grail you can use the Grail to directly chart those. So you don't have to materialize the metric as a time series. But I for convenience reasons, I extracted the metric right away.
I think also, folks, first of all, right, to remind you, if you have the one agent can automatically pull in those logs. If you don't have the one agent, you can also stream the logs using at least, FluentBit. You can use the OpenTelemetry collector and get the logs to Dynatrace. Then you can define the parsing, what we call DPL, Dynatrace pattern language, to define what is interesting for you on the log. And to your comment on the metrics, I think the benefit of doing it like this, you can then also create alerts on it. So you could, for instance, create an alert as, let's say, somebody is executing a very expensive query, you want to get an alert for it.
Yes, or usage pattern. What I saw, I will show you in the in the live demo then. There are some surprising effects that you can observe actually, right? And I will show you. And now I'm jumping to show you that in detail. Let me call the service first. So this is the conversational service. I'm not explicitly stating a question here. I'm just calling the OpenAI through those Golang services, through that stack multiple times here. And now let's see the example dashboard that I showed before. So basically what you see here is the number of requests going to OpenAI. The request latency, it varies here a bit. Of course, it would vary much more in terms of variance if the questions are different length. So if you have very lengthy questions, those requests would take much longer than that 1 second. And that's also interesting to see what your user base is asking OpenAI and how much cost is and latency is bound to that.
Yeah, I think an interesting question to ask here is you could even bucketize it. You could say, give me buckets of response length, and so that hey, no, 50% of our users are generating answers that are 100 words long.
Exactly.
And so that also how that impacts response time.
And that's exactly the topic of measuring and observing the behavior of your user base, how they use OpenAI, how they use an AI service. And cost, of course, is one of those topics that you see here. The number of prompt tokens, the number of completion tokens, and the total consumed tokens. And then what I did is, you see the last calls that I made, added some tokens additionally, right, in real time. And the cost here is pretty low because this metric, I'm calculating on the fly. So I can show you in Data Explorer how I did that. That's pretty easy. According to the price book, I'm calculating the sum of the total tokens that we measure in real time. We divide it by 1,000 and multiply it by 3 cents. So it's 3 cents per 1,000 token batch from OpenAI. It varies the price varies according to the model that you request. So that's the price for Da Vinci model. Right?
I can already envision that you could also build a notebook in the future where this data is pulled in dynamically from the OpenAI price book API and then
update that dynamically. And now I'm showing you an interesting story actually, because when I built that example, I observed an interesting spike. Let's see here of tokens used. And you see that here. So overall, I expected to only have several thousand or several hundred tokens for my example. But within 5 minutes, I consumed 18,000 tokens. I mean, overall, still pretty cheap, but it's worth to observe. And I exactly know what the reason is, right? The reason is that we have a security scanner scanning all the open web ports every day at 1 o'clock.
And
it scans for potential log4shell vulnerabilities, and it calls every endpoint with every combination of vulnerable endpoints. And that makes several thousand calls to my OpenAI service as well.
Wow.
So it drives cost here as well. And that's interesting and it shows how important it is to seamlessly observe the behavior of your service. Right?
And the good news is obviously you have all of the distributed traces, the pure paths. You can go back and actually look at this, and every single transaction that comes in, you can actually see the scanning tool on how it was actually calling.
Exactly. Yeah, and let's jump to see the service flow. You see exactly the flow of my front-end service that I called before to the model service, to the OpenAI client, how many calls there were, and then finally hitting the SaaS OpenAI service, returning the answer. What you also can see here is that we already have an open problem here where Davis kicked in. Davis automatically, as again, there was no change at all from the out-of-the-box behavior of Dynatrace, as its standard tracing capability, right? So all those relationships are automatically captured from the conversational service to the model service, OpenAI client, and OpenAI generative service as external web request service. And Davis identified OpenAI as being the root cause for a slowdown here. In this case, it's a bit of an example, of course, because I didn't use automatic baseline here, but a threshold that is unreasonable low, right, to show the example here.
But I think a good example of this would be if you are basically you're consuming an external API, you're paying for it. So that means you're expecting a certain SLA, a service level agreement, right?
Exactly.
And so this is also where you can actually teach the Davis AI and say, my SLA for this service is, let's say, 100 milliseconds. I'm also paying for it. So I want to be notified in case we are not meeting the SLA.
Exactly. That's exactly the reason. Yeah. But now let me show you how I captured the consumption metrics, because all the tracing is out of the box. I didn't have to do anything at all, right? So what you see here is the log line that I wrote, and you see the message here. So, and those are exactly, as you see, the calls that I made just right now. So the message that I send out is OpenAI response, and then I log out those numbers. And as you see here, that's a text message here, adding the service name here and the timestamp. And by setting up that log pattern extraction, you find it here. So I first have to process the incoming log message. I did show that already in the slide. You have a very neat previewer here, so that already shows what's going on. But this is the pattern, and it extracts those three fields here. And then I decided to also extract those three metrics, right? And And that's it. That's all that is necessary. And the neat thing here is that you can, after the fact, change it, of course. So you don't have to change your service implementation. You can immediately change on a change on the payload, for example, or whatever happens. You can, by configuration only.
And maybe one additional thing for people that are new to Dynatrace, all of this configuration can be fully automated. It's all settings 2.0. That means we have an API for it. We have a Terraform provider. We have Monaco, our own monitoring as code tool. So you can automatically roll out this configuration without any manual effort as well.
Yeah, and now I'm showing you some additional cool stuff that Andy brought me to, actually, or reminded me that by activating trace context enrichment, our one agent is able to automatically attach the trace ID to my log line that I wrote. I didn't do anything except write the log line, but by attaching the trace context here, that is done by the agent automatically, you see the host and so on, and the trace ID attached. And that means you can immediately jump from a log to a single trace.
That's awesome. So
then you see code level, what happened actually.
So this is now, folks, this is the distributed trace that we were capturing through the one agent. It could also be open telemetry, but because we are not only capturing your traces, but also your logs, and we put the context together, you can now actually do some really cool things. On the one side, you could analyze individual traces and get to the logs, but the reverse as well. You have a strange log message like, hey, you have a request that is executing 1,000 tokens. Now show me that request because I want to know who was sending it in.
Or a slow request and then go back to the logs for this trace. So it works the other way around too. And that's a super cool feature, actually. Very, very powerful. And to prove finally that I did nothing except writing a log line, I will show you my example code here, and you find it in my GitHub repo. So this is the call to OpenAI, right? I call DaVinci model, but you can call any kind of model they offer, and I prompt for some question that comes in as a string here. And for cost reasons, I just ask for 10 max tokens here. And then I get the completion back that contains the consumption information. And I just write one log line here that actually doesn't contain anything span or trace related. The trace context enrichment really is done fully automatically by the agent. So all I do is I write this text log line here.
And then this gets picked up by the one agent, gets correlated to the trace.
Right.
And then one more thing, because you mentioned in the very beginning, business events. It's also a feature that we have where the one agent can automatically capture HTTP requests and responses. That means for your OpenAI create completion, I assume it's making an HTTP call, obviously to the backend.
Right.
So even without the log message, you could tell a Dynatrace one agent to just capture the payload of the HTTP request and response.
Exactly.
And then you even don't need to add log lines anymore. But it's really great that you've basically shown us all the different options you have. Business events, no code change at all. Logs, if you already have a log, great. If not, very easy to add. And I think you also mentioned the custom metrics.
Exactly. Custom metrics is here. So what I do here is I simply create my metric, right? I add the consumption directly as a value, and then I ingest it locally at the agent side. That's all. But as you see here, I mean, the log version is much more convenient than. And additionally, of course, in this case, I already I'm bound to a metric name. I'm bound to a schema that I sent in, which I'm completely open on the log side, so I can change my mind after the fact.
Exactly, right. But it's great that you basically showed us all the options there are, and I think the power of logs here is just phenomenal because it gives you completely independent of this.
Absolutely. Yeah, and that was the OpenAI example, and that's one very prominent example of an externally hosted and built AI SaaS service, actually. But now I also brought with me another example I did several years ago when training my own in-house AI models. And that's built on top of TensorFlow and Keras. So Keras is basically the sequential API on top of TensorFlow, because TensorFlow in the raw version is a bit cumbersome to use. So there are multiple different ways of using TensorFlow, and Keras is one of the interfaces. And what I want to show now is how I can collect important training and production quality metrics out of my own trained AI model. One of the things I want to show here is that TensorFlow already, or the framework already comes with a very neat debugging tool, which is called TensorBoard. So TensorBoard is able to, so TensorFlow has the ability to write logs into and measurements, metrics into a folder, into a local folder, like a log file. And then you use TensorBoard to visualize the performance of your training effort. Right? TensorBoard is a great tool and also a great UI for local debugging purpose when training your model, but it's not so much fit for production running and observing, right? It was not built for production distributed rollout or something. But nevertheless, the same mechanism can be used to allow Dynatrace to receive the same kind of information. And that's really simple to achieve. You see here the Keras interface for, on the one hand, in the first line, to train a model. And then, I'm faking here a production run of the model, right, with a while true endless loop. But here the model evaluates with data. And the interesting part is here where you can register a callback. And the callback receives those metrics and those logs and information about the running model. And now I would like to jump to the demo here, showing you the TensorFlow model here. Basically, this is defining the sequential model in Keras on top of TensorFlow. That's all. So it's a neural network with multiple layers. And then I compile the model, and then I'm training the model. I'm just doing 5 epochs for training very fast, and then I run the model in production. I'm using the same callback here for training and for running the model in production. And let's now start the example here. You will see that the example starts with the 5 training epochs first.
And the callback, as this is running, that's, I could see there's like an import already. So we provide this as Dynatrace.
Yes, you can find it in the help page. It's I think it's 20 lines of Python code.
Okay, perfect. Yeah.
And you just use that, and it's an importer for Dynatrace.
Yeah.
So you see epoch 3.
So this is now we really see for those people that
is
new, this is the training of the model. Yeah.
And I mean, this is a very small example. Typically, those models are trained for weeks or days, as OpenAI, for example. I think the last training took them several weeks. So it's not that fast as in our example here. And then it runs, and you see already the logging of the loss and accuracy metric. And if I then jump over to Dynatrace again, and I'm checking the, where is it? Did I pin it somewhere? I checked the metric in Data Explorer. You will see TensorFlow accuracy and loss. You see the dimensionality is split by model and stage. So training and production. And the model is named. Let me switch to graph view and split it by model and stage. Then you see, well, the training is just one dot here, but that one dot even consists out of 5 measurements, because we had 5 epochs. So if you train it over days, then it's really interesting to see. And I said the wrong unit here. It's not dollar. But anyway, ignore that. And then you see the production run here, and at the model name.
So, but really cool. That means TensorFlow has a callback option that allows us to then, as it's training and as it's actually being used, to then take measurements, send it over to Dynatrace as a metric, and then obviously you can explore it in Data Explorer, you can put it on the dashboard, whatever you want with it.
Exactly. And additionally, what's pretty cool is that the TensorFlow extension mechanism not only allows me to receive accuracy and loss, but if you visualize your complete AI model in TensorBoard as a graph, as a computational graph, you can put your own sensors at each stage. So you can measure any kind of quality measurement for your own model, and that's automatically transferred here.
That's cool. I hope every data scientist is now excited about this. For me, this is all new, right? Because this is not the world that I live in, but I know many of our users live in this, and they actually have asked, how can Dynatrace help me to better leverage the AI models that we have? And I think you showed us how this works. So what we've seen today is, first of all, that by default, Dynatrace with the one agent can give you full end-to-end visibility into your apps that are using any type of API that allows you to communicate with an AI like OpenAI. I think what I learned, what's very important to understand the costs, because every request is measured by the complexity of the request and the response, and that's something you need to pay for if you're using an open API, for instance. The correlation between the logs and the traces was really great for diagnostic purposes, right? Show me the trace where I consumed 100,000 tokens. And then also TensorFlow, right? This not only works for public available APIs, but also for anything that you have trained in-house.
Exactly, yeah.
Cool. Well, Wolfgang, danke. Thank you so much for this.
Thanks for hosting me.
Yeah, of course. No, this is great. And folks, we will be back. Also, let us know, right? Make sure that maybe stop the sharing, then we can have the full screen. That would also be awesome. Folks, if you are interested in these topics, then just let us know. Also look at the links on the bottom of the description of this video. You mentioned the GitHub repository, so we'll do definitely the GitHub. We'll link that, the documentation, the blog post that you wrote. Yeah, cool. With this, bye.
Bye-bye.